Hey, 7th grade. We're gonna get back at it here with problem 2.2. Today it's gonna be looking at using tables, graphs, and equations. All right, so today, crossing the line 2.2, we're gonna go back and talk more about Henri and Emile and their little walking race that were set up. And so today we're gonna be looking at different ways that we can use tables, graphs, and equations to figure out where the line would cross in this situation. So here we go. Back in 2.1, for each brother, they asked us to make a table showing the distance from the starting line at several different times during the first 40 seconds. How can a table be used to find the length of the race? So I know we did this yesterday. I'm not sure if you guys saw it or not, but we're gonna go ahead and do some increments of time here when it comes to our table. So remember yesterday we made a table that looked like this. We got time, the distance for Henri, the distance for Emile. In that case, we'll do the exact same thing. So here we go for a 1. So we're gonna have our time. We'll do the distance for, I think we did for Henri. And then the distance for Emile. I'm gonna pause this here and get caught up. All right, so I made my table. We've got our time, distance for Henri, distance for Emile, and increments of 10 for each of those. So if you recall, for Henri, his situation was here. It's gonna be distance equals 1 plus t, or 1 times t plus 45. So I'm gonna put that 1 times t plus 45. And then over here, for Emile, his was 2.5 times t. So if I put 0 in here, 0 times 1 is going to be 0 plus 45 is 45. If I put 10 in here, 10 times 1 is going to be 10 plus 45 is going to be 55. If I put 20 in here, 20 times 1 plus 45 is going to be 65. And by now I can say I'm adding 10 every single time. And that's the case that we have for those. Other ones over here, we did a little bit of this work yesterday. So I'm going to use some of that work there from before. If I put 0 in here, it's going to be 0. Multiplying times 10, you can see I had 25. Multiplying it by 20 over here, I had 50. And by now I'm seeing a pattern, plus 25 plus 25. So I'm going to be at 75, and then I would be at 100 in this case. So the question comes in, asking us to make that table. How can a table be used to find the length of the race? Same situation. We want that length of a race that's going to allow for little brother Henri to win just barely before. And so we can see that it's going to be after 30 seconds, 75 meters is the distance. So we want the measure of the race to be about 74 meters, which is going to be a little bit less than that. So now for A2, they want us to graph the time and distance from the starting line on the same set of axes and how that graph can be used to find the length of the race. So we'll do that. And I'll pause here to get that set up. All right, here we go. For A2, they're wanting us to graph the time and distance on this axis. So if you want to pause here and copy the exact same graph that I've made, I know some of you may not have graph paper, but we have the spacing here. So I've got numbered counted by 10s going this way, counted by 20s going up this way to plot all those specific points.
So first thing, we get information here for Henri. So you can see that he's at 0, 45. So his first point is going to be 0, and 45 is going to be right around here. His next point is at 10, 55. So I've got 10 and 55. Then 20 and 65. 30 and 75. 40 and 85. So I'm going to use this here to draw that line. Next for Emile. So his is going to be 0, 0 to start. I've got 10, 25. 20 and 50. 30 and 75, 40 and 100. And if I take my ruler and draw it in there, you can see that goes all the way through.
So we have these two graphs to get an idea about where they cross. So then, again, the question comes in, how can we use a graph to find the length of the race? Well, we can use a graph to see where these two lines would cross, and they happen to cross at 30 seconds and 75 meters. All right, A3. A3 asks us to write an equation representing the relationship between time and distance. And we did that already. We actually had that from yesterday. So we could say specifically the distance for Henri is equal to 1 times the time plus 45. And the distance for Emile is equal to 2.5 times the time. And that's the way those will come in. So they're asking us, though, also to look at what information does each variable and number represent. So in this case, both cases, the d equals the distance in meters. The number 1 in this case and the 2.5, those are the walking rates. The t is the time in seconds. And the 45 equals the head start. A4. How does the walking rate of each brother show up in the graph, the table, and the equation? So here we go, A4. So the walking rate in the the table, well, you'll see that this is like every 10 seconds, there's 10 meters. So 10 seconds, 10 meters, 10 seconds, 10 meters. So his walking rate of 1 meter per second is there. Over here, you've got 10 seconds, 25 meters, 10 more seconds, another 25 meters. So basically you'd see if I did 25 divided by 10, it gives me that same 2.5. Remember that change of the y over the change of x. For example, if I had change of y over change of x would be 25 over 10, which would equal that 2.5. That's how you would show that change. In the table, how do we see that walking rate show up? Well, you can see that there's this walking rate of 1 meter per second is much slower than a walking rate of 2.5 meters per second. It makes sense that this would be a steeper line. So you can see that in this case, this is not a steep line because it is a slower walking rate. And then how do we see it in the equation? As we said up here before, the walking rates are going to be what's multiplied times the time. 2.5 and the 1 multiplied times the t tells us those particular cases. So I know I didn't write anything down, but we definitely talked through those in that. Next question, B1. How far does Emile walk in 20 seconds? Well, we can look at this very carefully because we can see that the distance for Emile right here, 20 seconds, is 50 meters. 50 meters in 20 seconds. Okay. B2. After 20 meters, how far apart are the brothers? How is the distance represented in the table and the graph? Okay, so 20 seconds we're talking about right here. Look at this. This is the 20-second spot. How far apart are they? Well, if I've got one person at 65, one person at 50, if I did 65 minus 50, they are 15 meters apart. And our question asks us specifically, how does that show up in the table? Well, you can see 65 and 50, you could subtract those two. And then how does that show up on the graph? This is actually an interesting one here too. If I had 20 seconds, you can see that this little span right in here. You can see right in here, this space at 20 seconds from here to here. That actually is 15, because remember each of these increments are 10 and then half of that would be 5. So you see that's that 15 right inside there. So you can see that spacing at 20 seconds. Number 3, is the point 2670 on either graph? Let's see. 26 would be right around here. So here's 25, so 26 would be a hair over. So if I'm gonna move up right here, 25 would come right here. 25 looks right on there, but 26 looks like it's a tiny bit above in that case. And it doesn't hit either graph, so you can see that it's not gonna be there. So in this case, no, not on either graph. And number 4, when will Henri overtake, when will Emile overtake Henri? So you can see right here, there's the walking rates coming in. They cross, like they are tied at 30 seconds right there. They're crossing at 30 seconds. So you can see that any time after 30 seconds, that's when Emile would pass Henri. All right, letter C. How can you determine which of the two lines will be steeper from the table of data and from the equation? All right, so part C here, steeper line. How do we see that? So if I look specifically at the table of data, we can see right here, this one's going up plus 10, plus 10, plus 10, plus 10. This is going up 25, 25, 25. I can see because the information is increasing at a faster rate for this table, this one would be steeper. Then how can I see it from the equation down here? Same thing. Our unit rate of 1 meter per second and 2.5 meters per second, this tells us this would be steeper because it is a bigger number. One is bigger than 2.5. All right, last little bit here, part D. At what points do Emile's and Henri's graphs cross the y-axis? Okay, y-axis is this vertical part over here. So when it comes specifically for Henri, his line crosses the y-axis at 0.45. And for Emile, this is the y-axis as well. His line crosses at 0, 0. So number 2 says, what information do these points represent in terms of the race? What does this mean in terms of the race? Well, we look at this before any time had gone by. There was a definite head start, if you recall from yesterday's lesson, that Emile gave Henri that 45 meter head start. So you can see that that's where that piece comes in. That's what that 0.45 means for his. And Emile had 0 head start, so that's why that shows up that way. Number 3, how can these points be found in the table and equation? Well, right here, we would find them by plugging 0 in for our time and working through that. In this case, you can see that 0.45 and 0, 0. And then for our equation, also the same exact work would be if we plugged 0 in for t and do the math, 0 in for t and do the math, you would see both of those. All right, so pretty straightforward, especially after yesterday's lesson, which was a little bit more of a starting point for this. They could have dumped these both into one lesson. But with that being said, I think that it should be making some pretty good sense. And so we're gonna look at the ACE work and practice those now. All right, so tonight you're gonna be working on 2 through 4 and 6. So here's question 2. 2.2, Emile's friend Gilberto joins the race. Gilberto has a head start of 20 meters and walks 2 meters per second. Write an equation for him. And then how would Gilberto's graph compare to Emile's and Henri's graph? Didn't say to make them, just how would it compare? Number 3, more information about some more people, Ingrid and Tara, and they're hanging out and doing some walking as well. And so you have something of a little bit of a head start and this idea of somebody catching up. So you use this graph to answer these questions down here. Number 4, they're giving you some information about student council asking for costs and estimates for a possible skating party for the end of the year. So 2 different businesses, Rollaway Skates and Wheelies and stuff. You have their details here. So they ask you, look at these very carefully. Are these going to be linear? They ask you to write an equation for these. What's the dependent? What's the independent variable? And then describe how you could use a table or a graph to find the cost of those two plans. And then number 6, the band decides to sell protein bars. You have the graph here and do this work as well. All right, have fun with that lesson, guys. It's a good one. And if you have any questions, I'll see you, either you can message me or I'll see you at the Google Meet at office hours on Wednesday. All right, bye.